Ever wondered just how vast our Milky Way truly is? To grasp its immense size, we first need to understand the staggering distances between the planets in our own cosmic backyard, the solar system. This is just the beginning. Beyond lies a scale so vast, it dwarfs everything within our solar neighborhood. These distances challenge our very comprehension of space and time. Our first stop is surprisingly close, yet profoundly significant: our very own moon. Positioned a mere 384,400 kilometers from Earth. To put this into perspective, imagine boarding an airplane cruising at a steady speed of 1,000 kilometers per hour. On a direct flight to the moon, it would take approximately 16 days of continuous travel to reach the lunar surface. In terms of communication, light, which zips through space at unimaginable speeds, takes about 1.28 seconds to bridge this gap between us and the moon. This results in a slight but noticeable delay in conversations of about 2.5 seconds for a message to travel back and forth, enough to disrupt the flow of a chat, making timely communication a bit tricky. But this delay becomes even more relevant as we shift our gaze further, setting our sights on Mars. The red planet, at its closest approach to Earth, stands about 56 million kilometers away. That same airplane, if it could somehow sustain a flight path to Mars, would take about 6.2 years to reach its destination. It takes light about 3 minutes to traverse this distance. This translates into a communication delay of at least 6 minutes for a round-trip message. In the context of space exploration, where precision is paramount, such delays aren't merely inconvenient, they could have critical implications. Commands sent to Mars rovers must be carefully planned, as real-time control is simply impossible. Now it's essential to clarify an important astronomical concept. The Sun-to-Earth distance measures approximately 150 million kilometers. There's often confusion about why this distance isn't a fixed number. The reason lies in the definition of an astronomical unit, which represents the average distance between Earth and the Sun, not a constant. Earth's orbit around the Sun is not a perfect circle, but an ellipse. This means that the distance between Earth and the Sun varies throughout the year. At its perihelion, or closest approach, Earth is about 147 million kilometers from the Sun. This occurs roughly 2 weeks after the December solstice. Conversely, at its aphelion, or farthest point, the distance stretches to 152 million kilometers, occurring about 2 weeks after the June solstice. This represents a difference of about 5 million kilometers throughout the year. Interestingly enough, Earth is farthest from the Sun during the summer in the northern hemisphere, a fact that surprises many given the warmth of the season. Is what truly drives our seasonal changes. It takes light, the fastest entity in the universe, about 8 minutes and 20 seconds, to traverse the vast expanse between the Earth and the Sun. Venturing further into our solar system, we reach Neptune, the most distant planet from the Sun, situated an average of 4.5 billion kilometers away, or 30 astronomical units. At this vast distance, sunlight takes 4 hours to journey from the Sun to Neptune. When Neptune and Earth align on the same side of the Sun, at their closest, the distance narrows to 4.3 billion kilometers. Imagining a flight to Neptune at the speed of an airplane, cruising at 1,000 kilometers per hour, it would take a staggering 490 years to complete this interplanetary journey, showcasing the immense scale of our solar system. Beyond the orbit of Neptune lies a frontier populated by dwarf planets, with Pluto, located about 39 astronomical units from the Sun, being the most renowned among them. Despite its remarkable distance, this region does not mark the threshold to interstellar space. That boundary is defined by the Helopause, the final known boundary between the heliosphere and interstellar space that is filled with material, especially plasma, not from our own Sun, but from other stars. Crossing the Helopause, we transition from the familiarity of our solar system into the vastness of interstellar space. Only 2 human-made objects, Voyager 1 and Voyager 2, have crossed this boundary. Here, distances stretch to truly staggering scales. For instance, Proxima Centauri, the star closest to our Sun, is located approximately over 40 trillion kilometers away. This equates to nearly 270,000 astronomical units. Within this interstellar realm, the scales and distances involved dwarf everything within our solar system, challenging our understanding and imagination of the scale of our galaxy. Within the Milky Way, the average distance between stars is about 316,000 astronomical units, illustrating the vastness of our galaxy. To comprehend such astronomical distances, we consider stars like Betelgeuse, one of the largest known, with a diameter surpassing the orbits of Mars or even Jupiter around the Sun. Nearly 700 times the size of our Sun, or about 1 billion kilometers in diameter, Betelgeuse is so bright that it can be easily found in the night sky, even though it's at about 650 light-years away. This red supergiant is so massive that if placed at the center of our solar system, it would engulf Mercury, Venus, Earth, Mars, and possibly even Jupiter. To put this colossal distance into perspective, consider the daily routine of an average, moderately active person who takes around 7,500 steps a day, equating to roughly 6 kilometers of walking every day. For most of the world, throughout most of human history, the average life expectancy from birth was around 24 years. This translates to a lifetime walking distance of approximately 50,000 kilometers for the average human. If we extrapolate this to the estimated 117 billion members of our species that have ever been born over the course of 300,000 years, the cumulative distance humanity has walked is over 6 quadrillion kilometers. Imagine if the entire human species could pass a baton from one member to the next, each walking their lifetime average distance. Collectively, we would reach Betelgeuse. Yet this staggering distance still represents less than 1% of our entire galaxy. In this thought experiment, it would take our species about 2.8 trillion years to journey across the space between the Sun and Betelgeuse. These numbers are way beyond what we're used to in everyday life, making it hard, if not impossible, for us to wrap our minds around them. For example, the Milky Way, our galactic home, spans approximately 100,000 light-years across. While we can articulate this number and even employ it in mathematical calculations, truly understanding the scale it represents is another matter entirely. Our minds struggle to visualize the enormity of our galaxy. Therefore, to better comprehend such immensity, we will compress and scale down the entire Milky Way to something more relatable, akin to the size of the Earth. If we were to compress the Milky Way, a galaxy that spans an astonishing 100,000 light-years across, down to the size of Earth, approximately 12,742 kilometers in diameter, we would be scaling the galaxy down by about 74 trillion times. This scaling helps us visualize the impossible. In this drastically scaled-down galaxy, the Sun, which in reality measures about 1.4 million kilometers in diameter, would shrink to less than the width of a human hair, approximately 18 micrometers in diameter. Meanwhile, Betelgeuse, one of the largest known stars and easily visible in the night sky from Earth, would find its place in this scaled-down version of our galaxy, just over 80 kilometers away. That's about the distance you might drive in an hour on the highway. The Milky Way, our galactic home stretching 100,000 light-years from one end to the other, is a vast expanse that challenges human comprehension. It contains between 100 and 400 billion stars, each potentially hosting its own planetary system. The last time light completed its journey across our galaxy, our ancestors, mere hunters and gatherers, roamed the Earth unaware of the cosmic structures unfolding across the heavens. They had yet to develop agriculture, build cities, or create written language, and yet, as immense as our galaxy is, it's but a single speck in a universe filled with an estimated 2 trillion galaxies. Each galaxy, with its own stars, planets, and potential life, contributes to the rich story of our universe, making it a place of infinite worlds beyond our own. The universe is far larger and more magnificent than we can possibly imagine.